Hello guys, this is Justin Bibilan and welcome to this episode of Don't Panic, It's Organic.
Ilalaban kahit kanino, oo, simple lang ako at malabo mong magtipuhan. Kaya okay nang kahit sa FB mo lang mapusuan. Kasi di na mapigilan ng sariling mapaibig sa iyo. Ano ba to? Gusto ka lagi.
Okay, let's proceed to the last topic for alkanes. These are actually reactions of alkanes and cycloalkanes. Okay, they're actually, I will just only give to you three reactions for alkanes. We have complete combustion, incomplete combustion, and halogenation for cycloalkanes and alkanes. So, complete combustion, so when we say combustion, is actually like you are burning or you are burning the hydrocarbons like alkanes or cycloalkanes to give you a product. Okay, so it's actually complete combustion because you are actually burning it at higher temperature. Then all of its components for alkanes and cycloalkanes are actually converted to carbon dioxide, water, and heat. So in order for that reaction to be considered as complete combustion, okay, the product should be carbon dioxide, water, and heat energy. Okay? And also, in order for the combustion to happen, you should have oxygen. Okay? Your starting material should have an oxygen. Because remember, if you don't have oxygen, then combustion will not happen eventually. Okay? So, oxygen is actually very important starting material for combustion. Okay? If you have an alkane plus oxygen, then you ignite it. So after ignition, then you are actually, if it undergoes complete combustion, then the product will be carbon dioxide, water, and heat energy. Okay? So if the product is carbon dioxide, water, and heat energy, automatically the reaction is a complete combustion reaction. Okay? So for example, if you have methane, so methane plus oxygen, okay, remember, your oxygen is a starting material. So you have an alkane, so methane. So methane plus oxygen, then the product would be, if it is a complete combustion, carbon dioxide, water, and heat energy. So automatically, if that is a complete combustion, all the alkanes and cycloalkanes are converted to carbon dioxide, water, and heat energy. And don't forget to balance your chemical reaction. So remember, so how do you gonna balance it? Okay, to balance your chemical reaction, the number of carbon on the reactant side, so this is actually reactant, okay, should have the same number of carbon on the product side. So, in balancing your hydrocarbons, you should balance first the carbon, followed by the hydrogen, then the last would now be oxygen. Okay, remember that? That is a technique. Balance first your carbon, followed by the hydrogen, then last would be the oxygen. Okay, so for example, CH4. How many carbon are there? There are only one carbon. And there's also one carbon on the product side. Okay, that is only taken from carbon dioxide. So your carbon is already balanced. How about on the uh, hydrogen? There are actually 4 hydrogens on the reactant. There are only 2 hydrogens for water. So you can put a coefficient or a number to balance your hydrogen. That would now be 2 times 2. So you cannot put here 3 because that becomes 3 times 2, that becomes 6. Okay, so that would be 2 times 2. That becomes 4. So there are already 4 hydrogens. So if you put coefficient 2 here, hydrogens would be balanced with the hydrogen on the reactant side. Okay, so gets. Then last would now be oxygen. So you count the total number of oxygen on the product side. So you have 2 oxygen here. How many oxygen there? There are actually 2 oxygen. Okay. Then plus you have 2 times 1. Okay, remember that when you put coefficient there, it's not just hydrogen is being multiplied, also the oxygen for water. So 2 times 1, that would be 2 oxygen. So how many total oxygen on the product side? There are actually 4 oxygen. Okay, now on the reactant side, this is only 2 oxygen. So to balance your oxygen, you put a coefficient 2. That becomes 2 times 2. That becomes 4. So now the balanced chemical reaction would now be this one. Okay. You have 1 molecule for methane plus 2 molecule for oxygen will yield 1 molecule for carbon dioxide plus 2 molecule for water plus heat energy. Okay, example, if you have cyclohexane, remember the cyclohexane is CnH2n. So if it is cyclohexane, so therefore carbon is 6. Then 2 times 6, that would be 12. So C6H12 plus oxygen, remember oxygen is a starting material, then it will yield carbon dioxide and water plus heat energy. The problem there is actually not this starting material and the product, because as you all know that the starting material should contain an alkane, an oxygen, then the product would now be carbon dioxide and water. Okay, the problem is how you gonna balance your chemical reaction. Okay, remember to balance chemical reaction or hydrocarbons, balance first your carbon, hydrogen, then the last would be the oxygen. Okay, so just practice how to balance this, because it's actually a basic in chemistry that you know how to balance your chemical reaction. So you should practice why this equation gets 9 molecules for O2 and 6 molecules for carbon dioxide and 6 moles for water. Okay, and you should also find some materials or link on the website or any tutorials that you can also learn how to balance chemical reaction, because I will not anymore discuss that here. Okay, so remember, for complete combustion, the product or the starting material should be alkane plus oxygen, then the product should be carbon dioxide, water, and heat energy. For incomplete combustion, it's the same alkane and alkane or cycloalkane plus oxygen is the starting material. However, the product may differ. It could be carbon monoxide, aldehyde, or the formation of carboxylic acid. So for example, if methane will undergo incomplete combustion, so you have methane plus oxygen, the product would now be, instead of carbon dioxide, the product is carbon monoxide plus water. Okay, so some combustions, especially if you are the gasolines in cars, okay, or in motorcycle, some of it are actually not undergo complete combustion. Some of them, some gasoline, your gasoline, the one that is in Petron or in Phoenix, are actually composed of alkanes. Don't you know that? Okay, they're actually composed of hydrocarbons. And that's why it's very flammable. Okay, some of these are actually, so this gasoline are actually burned in the by the machines of your motorcycle or cars. So it's actually burning, so it's a combustion. However, that combustion may not result to complete combustion that can be converted into carbon dioxide and water. However, some of it will just undergo incomplete combustion that will result to the production of carbon monoxide. That's why it is very it is not advisable for you, especially if you are like the taxi drivers. They are not advisable to go to their cars, to sleep on their cars that the aircon is off, okay? Because sometimes they just let it off and turn off everything, the machines, turn off the car, the aircon, and they just sleep inside the car. They lock everything, they close the window. It is not advisable because because the carbon monoxide will eventually be be accumulated, or it would be concentrated also inside the car, and it will be inhaled by the driver, and therefore carbon dioxide is actually a silent killer. Okay, don't you know that this is a silent killer, and that driver that is actually inhaled carbon monoxide will not anymore be awakened. Okay, he or she will sleep forever because this is actually a silent killer. It will stick to your hemoglobin, therefore your hemoglobin will not have enough oxygen to deliver into the brain. Therefore, your brain will lack oxygen because of the formation of because of carbon monoxide, and therefore the driver sleeping will sleep forever. Okay? So remember that it is not advisable to sleep inside the car that is actually a close. You turn off your aircon, you close the windows and everything. Okay? So this is already the formation of carbon dioxide. So this is an incomplete combustion. Or your methane can also form an aldehyde. So in this case, your methane can form a formaldehyde. Okay, you already knew. Where can you find formaldehyde? You can find formaldehyde in 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 a funeral homes, because the one that they use to for embalming a dead body is actually a formalin. That formalin is actually an aldehyde. So when formaldehyde mixed with water, it will actually form a formalin. So this formaldehyde is actually used for embalming, okay, for preserving dead tissues or dead bodies. Okay, or for methane or for ethane, if it undergoes incomplete combustion, it could form a carboxylic acid, which is actually acetic acid or ethanoic acid. Where can you find acetic acid? That is actually the main component for the vinegar, the one that is contributes to the sour taste of the vinegar. That is actually due to the acetic acid, or what we call the ethanoic acid. Okay, the last reaction would now be halogenation. So halogenation is from the root word halogen. So when you say halogen, so you would expect that the starting material would be composed of the halogens. So what are the halogens? Where can you find halogens in the periodic table? It's actually found in group 7. Okay, you have fluorine, chlorine, bromine, iodine. So these are all halogens. Okay? So when an alkane or cyclic alkanes are actually reacted with a halogen, it will actually form an alkyl halide or a haloalkane. Okay, so how do you do that? So for example, if you have alkane, then you have, so your halogens are actually in a diatomic form. So it's not monoatomic. Halogens are not monoatomic, but they are actually diatomic. Okay? Then, so for alkanes, if you are going to react this with halogen, with the presence of light or heat, then the formation would now be a monosubstituted alkane. Okay, monosubstituted alkane, that is actually monohalogenation for the alkane. Okay, so you say mono, that means one atom for your halogen is actually substituted to the hydrogen. So the hydrogen here is actually substituted with one halogen atom. That becomes, so let X be a halogen. Then you have a formation of an HX. Okay, so this hydrogen here is actually coming from that hydrogen, and that X here is actually coming from the X for halogen. Okay, so that's it. It's a monohalogenation for alkane. So the formation of an alkyl halide. So this is now your alkyl halide. Okay, then you have your hydrogen halide also as your product. So you have alkane plus halogen, and you have light or heat. So the product would be an alkyl halide or hydrogen halide. So for example, if you have methane plus bromine. So bromine is a halogen. So you would expect that this hydrogen would be substituted with one Br. So it would be substituted with one Br to form methyl bromide or bromomethane, and plus a hydrogen bromide or HBr. Okay? Easy. So next, how about if you have ethane? So you have ethane plus Cl2. So one of the hydrogen. So this is actually monochlorination. So the previous one is monobromination. This one is monochlorination. So that means only one Cl is actually substituted to your alkane. So one hydrogen is lost. A Cl is substituted to that hydrogen lost. So therefore, this is a formation of chloroethane plus a hydrogen chloride. Monochlorination for cyclohexane. So one hydrogen is lost. So therefore, the formation of chlorocyclohexane plus hydrogen chloride. So it's just very easy and very basic. Okay, so if the problem says it's a monochlorination or monobromination, then you would expect that one halogen is actually attached or substituted to your alkanes or cyclic alkanes. So if halogen is allowed to react continually, so remember that it is only monohalogenation. That means you are actually substituting a hydrogen with one halogen atoms. Okay? But if you are going to allow the hydrogen to react continually, then the alkyl halide that is formed may react also with another halogen atoms. Remember this one, for example, if this alkyl halide will react with another chlorine in the presence of light or heat, then the hydrogen, do you remember that this carbon has two hydrogens left? So it could also be substituted with another halogen and then another halogen. And this one also could also be substituted with another halogen, until all of the hydrogens are actually there are no more hydrogens left. All of the hydrogens are actually substituted with your halogens. Okay, so for example, I have here an example. So for example, I have methane. So methane plus Br2, this is bromination for methane, plus heat. Then you would expect that your hydrogen from your methane would be lost. Okay, so your Br would be substituted to that hydrogen, that you will form a bromomethane plus a hydrogen bromide. If your bromomethane, which is an alkyl halide, will react continually with your with Br2, okay, so that hydrogen there will actually be substituted with another Br. So that becomes CH2Br2, because that hydrogen will be substituted. So you will lose hydrogen, that becomes CH2, and you will add another Br. Okay, so Br. So your CH3Br will be added with another Br, and your hydrogen will leave, okay, to form another HBr. So that becomes CH2Br2. And if your CH2Br2 will continually react with your Br2 in the presence of heat, then that hydrogen will also be substituted with the Br. So you have only one hydrogen left, and you have 3 Br that is actually there already. Now, if this tribromomethane is actually react continually with Br2, then that hydrogen will also be substituted with your Br to form CBr4. And since there are already no hydrogen on your composition of your formula for this compound, all of the carbon are actually the bonded with your Br, 4Br. So therefore, there are no hydrogens left. Then you will, then if you are going there, then there will be no further reaction if you are going to react this again with your Br2 in the presence of heat. Okay, so this would now be your final product. So alkanes and cycloalkanes, if you are going to allow them to react continually with the halogens, then therefore the hydrogens there are actually being substituted with the halogens. Okay, so if there are 6 hydrogens present on that compound, then if you're going to react that alkane with the halogens, then all of that 6 hydrogens would also be substituted with the halogens. Okay? Going back, and also number 2. In more complex alkanes, halogens can occur to some extent at all positions to give a mixture of monosubstituted products. This is actually very common for those in those 3 carbon like propane, propane above, because you can actually form products. Like for example, for propane. So you have propane, the chemical formula would now be 3 CH3 CH2 CH3. Okay? So if you're going to undergo this with monochlorination, okay, the presence of heat, okay. So propane, you are going to halogenate this, okay, by monosubstitution for chlorine with this. So you would expect that the product would, this hydrogen here will actually be substituted. So this hydrogen will be substituted with your 1Cl. Am I right? Okay, then you will form with, and you will form a CH3. What would be your product? That is actually an alkyl halide. So CH3, CH2, CH2, okay, CH2, because one hydrogen is lost, CH2Cl, okay? That would be your product. However, okay, your Cl also can actually substitute this hydrogen at the second carbon. Okay, that will also be substituted. Then you will expect to have a mixture of a monosubstituted products. Then therefore, the product would also contain CH3. Okay, that becomes CH3, CH2, or CH, because one hydrogen is substituted with a Cl, so CHCl, then you have your CH3. Okay. So this would now be the mixture of that product, then plus HCl. Plus HCl. Okay? So remember that this hydrogen can also be substituted with your Cl because they are different products. This one is 1-chloropropane. The other one is 2-chloropropane. The question, sir, why this hydrogen would not be also substituted? It can be substituted, monosubstituted with your Cl. But if you are going to substitute this with a Cl, then you would expect that the product would also be the same as 1-chloropropane. This would also be the product for this. Am I right? Because if you are going to substitute this with Cl, you lost this hydrogen, that becomes 2. Then you would have the same product as this. Okay, remember Cl, CH2, CH2, CH3. This is actually Cl, CH2, CH2, CH3. That's the same. That is also 1-chloropropane. Okay, however, if you are going to monosubstitute the second carbon, you would expect a different monosubstituted products. Okay, that becomes 2-chloropropane. Okay, so that is the basic concept for that. And remember also to balance your chemical reaction. This has not been balanced. So if I'm going to balance this with, uh, if we're going to balance this, I will erase this. Okay, you have 3 for that. Okay, this would be 3. Oh, pen. Okay, so that be. If I'm going to balance this, I'm actually putting 2 of this and 2 HCl. That's it. That's already balanced. No, that's not balanced. Okay, you have also 2 Cl2 because you have 4 Cl. 1, 2, then 3 and 4. So that is the balanced reaction for that. So I have here a sample problem for reactions of alkanes and cycloalkanes. The question is, write a balance equation for each of the following reactions. Show all possible products. Okay, number 1, complete combustion of cyclobutane. So remember your cycloalkanes. What is the formula for cycloalkane? You have CnH2n. Okay. So if you're going to draw your cyclobutane, that is actually a 4-carbon ring. Okay. So you can actually draw it as a square. Okay, because that is your 4-carbon ring that shows or that represent your cyclobutane. But its molecular formula that would be, so CnH2n, that becomes C4H. So 2 times 4, that is actually 8. So the molecular formula for cyclobutane is C4H8. So it's actually complete combustion. Then you would expect starting material would be an alkane, or a cycloalkane, plus what is the other starting material for combustion? You have your oxygen gas. Okay, that's correct. Then, since it is a complete combustion, then you would expect a product to be carbon dioxide plus water. Very good. Because it is a complete combustion. And also, you have evolution of heat energy as your final product for that. So the problem now would be how you're going to balance your chemical equation. Okay, so what did you learn about balancing? First, you're going to balance balancing your alkanes, the combustion. First, you're going to balance the carbon, followed by the hydrogen, and last would be your oxygen. Okay, so how many carbons are there in your reactant? There are actually 4 carbons. But on the product side, there are only 1 carbon. So you will put 4 coefficient before the carbon dioxide so that your carbon would now be balanced. So you have 4 carbon. Okay, you have 4 carbon on the reactant, and you have also 4 carbon on the product side. Next, you are going to balance is the hydrogen. Okay, how many hydrogens are there? There are 8 hydrogens on the reactant side. So how many hydrogens are in the product side? There are 2 hydrogens. So to balance your hydrogen, you will put 4 also there before the water. Okay, so that 4 times 2, you will now have 8 hydrogens. That will also balance your hydrogens in the starting material or in the reactant side. And last would be the oxygen. Okay, so how many oxygen are in the product side? You have 4 times 2, that becomes 8. Plus 4 times 1, that is 4. So 4 plus 8, that becomes how many oxygen? You have 12 oxygen. So to balance your oxygen on the reactant side, there are actually 2 oxygen on the reactant side. So in order for it to have 12 oxygen, then you will put a coefficient 6 before the oxygen. Okay? So that becomes 6 times 2, that is 12. And this is now your balanced chemical equation for the complete combustion of cyclobutane. Okay, next. you have monobromination of propane. So it's a monobromination, so you would expect that the halogen would be a bromine, correct? So it's a propane. So what is the condensed formula for propane? You have CH3, CH3, CH2, and you have CH3. So it is halogenation with the presence of, because you have your bromine is your halogen. It's a diatomic, so that should be Br2. So it will undergo monobromination in the presence of light or heat. Okay. So you can either put light or you input heat. Okay, for this reaction. So it's a monobromination. And remember that the problem states that you should show all possible products. So there are actually two possible products for the monobromination for propane. Because you can have monosubstituted for carbon number 1, and you can also to have a product that is actually monosubstituted for carbon number 2. So you would expect to have a product which is actually a 1-chloropropane, that is CH3CH2, CH2Cl, not Cl but Br, 1 bromopropane. Okay, I mean 1 bromopropane because it's a bromination. Okay, so 1 bromopropane plus, you can also to have a product which is actually 2 bromopropane. Okay, so you have two products for this because your carbon number 1 can also be monosubstituted with your Br, and also your carbon number 2 would also be substituted with your Br. So you have 2 bromopropane. And also, the last product would now be the formation of a hydrogen halide, which is hydrogen bromide. So HBr. Okay, then remember to balance your chemical formula or chemical equation. So that would be 2 propane. Would also expect 2 Br2 and also 2 HBr for this. So you have 2 propane, 2 Br2, that becomes 4 Br. So you have 1, 2, 3, and 4. That is 2 times Br. That becomes 2 Br. Then you have also 2 Br there. That is 4 Br. Okay, then you have 2 CH3, CH2, CH3 also. This one, and that 2 hydrogens also, that are actually being substituted with carbon number 1 and carbon number 2, that is actually 2 hydrogens. Okay, so this is now the chemical or the balanced chemical equation for the monobromination for propane. So you would expect two products. You have 1 bromopropane and 2 bromopropane. Okay, next. Okay, for number 3, you can pause this video so that you'll be able also to predict the product for the complete combustion of ethane. However, we'll also give you the answer for that. Okay, you try to answer this. So number 3, complete combustion of ethane. So what would be the condensed formula for ethane? That would be CH3, CH2, or CH3, CH3. Okay, because your ethane has only, that is actually an alkane with 2 carbons. Okay, so the condensed formula would now be CH3, CH3, or you can also write the molecular formula, which is C2H6. Okay, so C2H6. Remember, it is a complete combustion, so therefore the starting material should be an alkane plus your oxygen. Okay, plus oxygen. So therefore, it is a complete combustion. The product would now be carbon dioxide plus water plus heat. Okay, the evolution of heat for combustion reaction. Now is to balance your chemical equation. Okay, how many carbon? So remember to balance it. Balance your carbon, then hydrogen, then last would be your oxygen. So How many carbons in the starting material? There are 2 carbons. How about in the product? 1 carbon. So you're going to put a coefficient 2 there to balance your carbon. How many hydrogens? 6. There are only 2 hydrogens on the product side. So therefore, you're going to put 3 hydrogens as your coefficient for water in order to balance your hydrogen. Total oxygen, you have 4. 2 times 2, that is 4. Plus 3 times 1, that would be 3. So how many oxygen are there? There are actually 7 oxygen on the product side. But there are only 2 oxygen on the on the reactant side. So how do you make it a 7? You write 7 over 2. Or 7 over 2 is actually 3.5. So 3.5 times 2, that becomes 7. But in balancing chemical equation, there should be no, the coefficient should be not a decimal or a fraction. All of the coefficients should be actually a whole number. So in order for this to become a whole number, you multiply everything by 2. So that these 2 here will also be cancelled. And the final answer would now be, for the balance reaction, would now be, you have 2, okay, you have 2CH3, we'll just give the molecular formula, 2C2H6 plus, so 7 over 2 times 2, that becomes 7, so 7O2, 2 times 2, that becomes 4 CO2 plus 2 times 3, that becomes 6 H2O. So this would now be your final answer. And of course, don't forget plus heat. Okay? A triangle is a symbol for heat. Okay. So check your final answer. You have 2 times 2, that becomes 4. So you have 4 carbon. 2 times 6, that is 12 hydrogen. 6 times 2, that is 12. 4 times 2, that becomes 8. 6 plus 1, that is 6. 8 plus 6 is 14. 7 times 2, that is 14. So this will now be your final balanced chemical reaction for the combustion of ethane. Okay, next. You have monochlorination of butane. Okay, what would be the condensed formula for butane? You have CH3, okay, CH3, CH2, CH2, then you have CH3. So it is a monochlorination, so therefore the addition of your halogen would be chlorine. So in the presence of light or heat. So I will only put heat here. Okay, what do you expect to be the possible products? So actually you have 2 products for this. One is your carbon number 1 is actually substituted with your Cl, and also your carbon number 2 would also be monosubstituted with your Cl. Your carbon number 3 would also be substituted with a Cl, but with the same the same result as your carbon number 2, because you will not to name your products to be 3-chlorobutane. There is no 3-chlorobutane, but it's actually a 2-chlorobutane. Okay, so you would only expect to have a product that is actually 1-chlorobutane and 2-chlorobutane. So the product would now be 1-chlorobutane, so that is CH2 and Cl. Okay. Then you have also 2-chlorobutane. Okay. So in this case, you can write your chlorine here or in this portion here. Okay, you can also write the chlorine there. So it's just the same as writing your chlorine there, because that is the same name, 2-chlorobutane. Then don't forget your plus HCl. Okay, plus a hydrogen halide. So you have mixture of your products for monochlorination for butane. You have 1-chlorobutane and 2-chlorobutane. Then you balance your chemical equation. There are 2 here, 2 butane, 2 Cl2, then you have 2 HCl, then you're done.